Usually, if you look at the design, it's like the top-down, the floor plan, like a function, like where's the main living room, where do you want to put the toilet, etc. Okay, that's the function it plays. Another concern of a building, which is when people talk about architecture, most of the time is about actually the physical constraint. Okay, what is the main physical constraint a building is dealing with? It's called gravity. It's called gravity. Okay, and some other things like it need to withstand the earthquake. I guess it's gravity again. Okay, is wind also related? And rain, so you need roof. Yes. What is the gravity in software? If you didn't know, now you know. It's called entropy. Usually it depends on the major purpose of this building. For example, is it a temple, or is it or is it for a recreational park, right? So like this is a very famous building in Singapore. It looks very picturesque. That's the language they use to describe a building. So of course it's not formal, but it's a bit futuristic. So these are the three aspects when you talk about a building architecture. Okay, so now I'm trying to map that to software architecture in a very awkward way. So as I said in the beginning, that this is exactly what a bad architect would do. Okay, to make things simple, I'm going to remove the aesthetic perspective, the appearance. I think it's still relevant to software architecture, but just I don't want to make too many dimensions because I want to introduce a new one. I think if I remove the beauty perspective, okay, there are two things still there. One is the functionalities, okay, the functionalities, and the other thing is what are the things that keeps the software maintainable. Okay, in terms of like physical building, is what is the design that keeps the building stand without collapsing and kills everyone. Okay, that's when a physical building fails. What happens when a software fails? You might be thinking it has bugs or it crashes. That's not when a software fails. That's still about functionality. A software fail is when it becomes a dead need. So you still have the software, but nobody can do anything about it anymore. Okay, you cannot change it anymore. That's when a building fails. That's when a software fails. So the things that keeps the software maintainable. What are the things that keep software maintainable? Tests, automated tests, I guess, right? And what else? So, sorry? Documents. Yeah, documents are important. Yeah, as long as they don't lie, right? And probably also things like if the code can explain itself, that can help, right? Those are the things that keeps the software maintainable. I think quite a lot of businesses, they rely on their teams, rely on the memory of their teams. So you have this team, they are the expert of this software. So they are making sure my software is maintainable. Okay, good luck for them because people do leave and people do forget, and people make mistakes. Okay, so these are codes, config, or packaging. So they make the software, and these are sometimes automated tests. Type checking is important. Okay, so if you use a strong type checks, those can also help you to keep the integrity of your software. Okay, so I removed the beauty perspective of the building architecture. So add a new one, which is time. Okay, the time in some culture. So I think in English the expression is the future. You are facing the future, right? In some culture, you are actually like having your back towards the future. So the future actually comes from behind. So it's a pretty interesting perspective. If you think about it, it's quite real and a bit scary. If we put time there, then this is how I understand what is software development, okay? So you will have a product backlog. That is pretty much the thing you plan to do. There will be items in it, and they are, basically you will do them one by one, okay? That's, no matter how you plan it, how you get your backlog, these are the things that's going to happen. For me, I know it's an awful, bad metaphor. They are like small missiles. Okay, they are. They come in different sizes. Everybody knows if your product backlog is properly refined, the immediate items should be smaller, and the later ones should be, in course, bigger in size. But they every of them load with different amount of charges. Okay, and this become a bit more literal. When you start to do them, you take one of them, and you make what do they call it? Impact. I know it's probably not the original meaning of the word impact in the sense of impact mapping. But I'm stealing the word to make it more meaningful. Here, I make the impact a bit more literal, so that you make a mass. Okay, you make some change so that your product start to have more functionalities. Okay, but in the meanwhile, it has some impact on the maintainability. Okay, what do you do after you make such a mess on your product? You still need to clean up, make sure the product functionality is in a good shape, integrated shape, rather than following just the timeline. Okay, you don't want to leave a trace of your user stories or backup items. But also you need to make sure these things are maintainable. Okay, so this is basically what you. If you say a company says I have this software system, what does it mean? It's basically these functionalities plus the things that make them maintainable. So this space is what you have. Okay. This is my understanding about the dynamic of making software. Understanding this maybe help you understand my following point. So what I'm going to talk about is mostly two aspects. You can say when I'm making software, okay, especially trying to make the software maintainable, which side should I listen to? Working software or the domain? Okay? Well, put it in a different word. I'm actually comparing extreme programming to domain-driven design. Okay? I mean, I don't have to tell this at the very end. I can already tell you now. They are both very important. We need them all. Okay? But I put them in a contrast to as I said, just let's review all this knowledge together. Okay, I will have some code. Okay, but I'm not going to go through the detail. I guess this is this will be at a very high abstract level, and I feel a little bit ashamed about that already. Okay, so my journey and the confusion. Very early on in my career of being a software developer, I learned this from Ken Beck. When making software, you want to make it work first. Okay, so make it functionally work. Okay, which probably, if you look at the code, just a piece of junk. But then, only then, you make it right. Make it right doesn't mean you correct the functionality. The functionality should be there already. Okay, only then you make it right means you refactor your code. So make sure the code is maintainable. Okay. And after that, you make it fast. Meaning, make it fast is in general meaning like a performance improvement. If it's not fast enough, you make it fast. Okay. If you do make it fast, if you think my software needs to be fast, okay, and you make it fast first, chances are, in the end of the day, the design will be not right. And does it work? Maybe it doesn't work properly. Do you think it's fast? It won't be fast either. So these three things need to be in sequence. By the way, this picture doesn't really make too much sense. Okay, it's explaining very different concepts. Because make it work, make it right, make it fast. The functionality perspectives should be exactly the same. And these are three very different things. Okay, so that's where I start. I don't have the slides here, but let me maybe tell the entire idea at one go, so that if you're in a hurry, you can be hurried. I will have detailed the slides to explain the points. So on one side, some of my masters, the people I follow, okay, especially Ken Beck, tell us, okay, so you need to listen to your code, listen to your working software, because everyone thinks computers are smart, okay. Only you guys, the software developers, understand the computers are actually very, very stupid. You have to tell it every detail, otherwise you simply won't work. So if you are using a C or C++, or Java, even missing a semicolon doesn't work. What kind of smartness is that, right? This is very, very stupid. But what if your software is already working? What if your software is already working? That means all the wisdom that is needed to make it work is already there. It's already in your code. Therefore, you don't need to look anywhere else. All you need to do is to just look at your working software, because your code will tell you what is the proper structure. Okay? You just need to look inside. Okay? Now, if you think about it, this is not really related to the problem you are solving, right? It's entirely about the internal structure of your code. This is one school of thinking. So the vanilla version of TDD is mostly about this. Okay. On the other side, there are some other masters. They say differently. They say, come on, no. You are working for a domain to solve business problems, right? Therefore, it's wrong if anything else is driving. Right? The domain should be the one driving, because you are solving the domain problems, right? Now, let's say, if your business solution, if your solution and the business domain, they are the same, it will serve the business domain the most efficient, right? Not only that, in the future, if the business domain change, your solution will only need to change accordingly. If you have a different structure than in your solution than your business domain, then probably a small change in business domain will lead to a very big change in the structure. Okay? So, and on top of that, so the cost of learning is much lower if these two things are overlapping, right? Chances are, if you are a software developer, you understand the code. You can also understand the business. If you understand the business, you should be able to read the code as well, if you design it properly. Okay? So, domain should be the one driving. Then I'm a bit confused. I mean, then should I make it work first? Or should I get the domain clear first? Okay? So personally, I went the other way, the working software way a bit early on, and I probably explored more. Partially because I worked in Nokia for many years. That was 10 years ago, but I worked there a long time. So. And in telecommunication, the domain is kind of weird because everything is defined already. There's a industry standard. You just follow that, okay? And so there's no much domain. And in the domain, everything is made up because there's no real stuff. Like you don't really see a channel, right, in the communication stuff. So I didn't get to explore. I wasn't exposed too much to the domain during the design perspective. But later, I got some experience in that. Okay, let's get into the detailed bit. First, let's talk about test-driven development. This is just a review. Everyone knows TDD, right? And I guess everyone practices TDD, right? Yes. If not, you don't have to tell everyone, right? So go back and make sure next time you come to such a talk, you can confidently say yes. What do you do if you are doing TDD first?
Write test.
You write a test. What kind of test?
Good question.
A failing test. Okay. How many of them? Just one. Okay. One. You make it. You write a failing test. Then what do you do? You run it to see it fail. Okay. You know it failed. Is it good enough? That's not good enough. You run and see it fail. Come on. You don't have to process everything in your brain. Let the CPU work, okay? So run and see it fail. And then what do you do? It failed? Okay, yeah, there are people knowing this is really good because it's not done yet. You read the message. Is it failing for the right reason? You might think it failed and you go to fix it. Actually, you're fixing a different problem. You need to read the message, see if it's intended. Or you need to read the message so that you know next time if this test is failing for real, the message is helpful, the message is useful. Then you fix the message so that it's useful next time when they actually fail. So that the next person, he doesn't need to do debugging. Okay, he can immediately fix it. This is how we make it maintainable. Okay, so my run my test fail, and the message is meaningful. It's exactly what I expected. What do I do next? You write code. Write the easiest, simplest, the most simple solution. That's just enough to pass your test. Okay? We call it the easy change. And then you run it to see it pass. Knowing it will pass is not good enough. And then what do you do? You do refactoring, okay? You do refactoring in every loop, okay? Not just at the very end. See, we only passed one test, and we did some very simple implementation, but we need to refactor immediately, okay? And then after refactor is to improve your code. After you improve it, so here we also call it Marie Kondoing. Anybody know who Marie Kondo is? If you don't know, Google her. You'll have some good YouTube time. So when you feel that you have done enough, you can move on to write the next test. Okay? How long is one cycle? This is called a TDD cycle. How much time does it take? 3 minutes, 3 minutes, 5 minutes. Some people say this depends. It doesn't really depend. Because no matter how complicated your problem is, you can always just test for a very small increment. Okay? So it should be very fast, just a few minutes. Let's focus on refactoring a little bit more. What is refactoring? Give me the book version of definition. That's the book. You change the internal structure, yes, without changing external behavior. Okay, how do you know the external behavior didn't change? All the tests should still pass. Okay, more than that, you need to be more disciplined than that. You cannot secretly add new behavior when you are refactoring. Right? So having the existing paths is not enough. You cannot add new behavior. Changing the internal structure. What is the internal structure? Do you have a different word for it? The internal structure of your code? The code, the thing we are looking for is design. Okay? Is you are doing design. Now this is very interesting. When you start to write your test, do you have a design? You have a design. You only try to understand what do I need to do, right? What the customer need. When you try to make the test pass, do you have a design? It's too shameful to call that ugly thing a design, right? It doesn't have a design in it. It's just simply work. It just work. When do you have a design? Only after you have the working software, you start to have a design. So you see, this is how you listen to your code and start to have a design. I'll skip the example, okay? There's some examples. By the way, you have a failing test, and then you do the easiest thing to make it pass, and then you refactor. This time, probably there's nothing to refactor, and then you write more tests, more code, and then this time, probably there's something to refactor, and then you write more code, more tests, more code, and more refactoring. At some point, so you let me maybe show the last one. After this one more TDD cycle, you see your software start to look like that. The shape start to look like that, and you look at it. You're like, this doesn't look like this doesn't seem right. So you start to refactor. I don't have that slice, so I should have another slice like this. One piece of software become modularized. Okay, but I forgot to add it. Okay, here are the masters. Okay, they were like code. Listen, you shall, as Yuda would say. Okay? Like, you guys are all so young that you probably don't understand this Yuda expression. Okay, or as the bird said, let design be the way it wants to be. These are really good, like very, very high level abstract sayings, right? But these are what the masters said. And a little bit dive deeper into it is these are mostly not dependent to the domain. It has actually very little to do with which domain it's from. And these principles, if you dive deeper into it, are mostly belongs to two sides. Or actually it's one principle in general. It's called high cohesion, low coupling, or loose coupling. Okay. So what is high cohesion? High cohesion means things belong together, need to stay together. For example, scissors. Okay, I don't know what's in Thai, but in English it's a plural, so scissors, because there are two pieces. Okay, do you keep them separately? Like every time you want to cut something, you are holding one piece of scissor and where's the other scissor? It's not convenient, right? So you keep them together. Low coupling is how things are related to each other. How much do you know each other? Like this mechanism, it can pass the rotation without passing the some of the direction of the movement. So that's a loose coupling. So in the on Wikipedia, you can have a very good picture explaining coupling and cohesion. You can see in each submodule how much the functionalities inside they related to each other is the degree they are cohesive. And between the two submodules, how much they depend on each other, that is how much they couple. Okay, so in the end, you want a loose couple system with high cohesion. When you are listening to your code, basically these are the principles, okay, supporting the refactoring. One of my conclusions later I'm going to share is these are the theories. You do them. Do you do theory? No, you don't do theory. You do practices. Okay. So when you are refactoring, what are you looking for, by the way? You're looking for code smells, right? And the code smells are based on these design principles. And you find the code smells and remove them. Those are the practices you do. These are just theory behind them. If you read the design books, okay, most of them are actually talking about this kind of design principles. They are domain independent. Well, in the meanwhile, some other masters, as I said, they were like, you need to focus on the business domain. Otherwise, you're doing the wrong thing. Okay? Or like the bird said, let the business people and developers speak the common language. How do you spell ubiquitous? It's a U-B-I. Come on, just common language, just same meaning. I don't know why they made it so complicated. So meaning the business domain and the solution domain, they use the same language. Okay, so these are I don't have a very complete picture. Some of the ideas, some of the principles used in the domain-dependent school of thinking. Okay, including direct mapping and ubiquitous language, bounded context, and the very key concept here is the domain experts. So domain experts and the development team need to work together. This is unfortunately quite often missing. So when I'm practicing DDD related stuff, one of my puzzle is, where are the domain experts? Where are the domain experts? Usually they are pretty hard to find. Quite often we call these people domain experts. So they are the translators. They go between business domain and development teams, okay, passing informations. They are usually like business analysts. This is probably not really the kind of domain expert we are looking for. So it really depends on which industry you are working on. Some industry, there are domain experts. Probably they have a deep understanding of the analytic perspective of the problem they are working on. Some just have no clue, and actually asking for them doesn't really help. Because they do not think about the domain in a logical way. So this is quite controversial. Eventually, I'll leak another information I'm going to share later on, which is kind of spoil boss talk later on, the closing keynote today, a little bit, is as a software developer, a programmer, one of a journey we probably need to start is to gradually become a product developer rather than just a software developer. Okay, so in the end of the day, you will become the expert, okay, of not only the solution domain. So another topic I want to share a little bit is about the bounded context. This is too big to ignore. Okay, I'm not the right person to explain this, so I'm going to make a few metaphors. If you think about it, I'm talking about the veil house here. Okay, when we go shopping, mostly our cloth is divided into you can simply say shirts or pants. Okay, and if you think about it, it's amazing. You go to, for example, let's say just shirt. You go to a shop, and there are just a few choices: small, medium, large, extra large, and that's it. And chances are most of us just fit. So, but if you look at the human body, everybody is so unique. It's very hard to imagine that we can come up with a so efficient generalization. Okay, it's probably still easier for men. Okay, not because we're PT, but also because of army actually. If you join the army, they measure everyone, measure everything. So they have the data. I'm still, the female sizing is still something like ethical for me. Because they have more, let's not go there, but you know what I'm talking about, right? Right? Then, these are few sizes, just work, okay? Now, in domain-driven design, we're also looking for this. But to shorten this 50-year journey of seeking for proper sizing for everyone, can you just make a decision in one workshop and it just work? The chance is very, very low. But however, many of the design is based on this because the boundary is clear and then you have more links in between and usually it leads to solution like microservices. Okay, because each of the bounded context it has more to do with internal stuff rather than between the context. Okay, this is based on this assumption. If we divide the software into smaller services, the teams can have more independent work so that they can work in a context without being interrupted by the others. Okay, another spoiler for the for boss talk later. If you think about it, okay, just now we look at the cohesion and coupling a little bit. Okay, I have to say this is very shallow. Okay, a lot of my talk is influenced by an upcoming book written by Ken Beck called Tidy First. The draft book. Actually, a lot of things I'm going to share I get the idea from there. Okay, if you want to learn more about cohesion and coupling, probably you can get some hint from that book. He promised to share more in his next book. If you think about it, bounded context and microservices, they are about cohesion or coupling. They are mostly decoupling, right? Now, however, one of my mentors, Craig Lahman, he said, but cohesion has higher priority. Really? Cohesion has higher priority because coupling. Let's think about it. If you do it now versus do it later, is there any difference? I mean, the cost perspective. If you have the option, okay, of decoupling it, but you don't do it.
If you get it wrong, it's going to be so much difficult to like retype it and reslice it.
I'm saying that you leave the option open. So what you said is you kill the option, right? So if you leave the option open without killing it, Okay, so you do it now and do it later is the same, right? However, nobody does the evaluation for how much option you have in your software though. That's probably, I think, a kind of business you can do. Like to go to software and see, your software, although it doesn't have feature, but it has options. I think it might be a good business to do, okay? So probably we can consider to refactor to microservices, okay? I will have to fast forward. Okay, yeah. So I will share, go directly to this part, my learnings, okay? And I will fast forward the first part, share the dry part. This is a bigger picture for the content I share. The upper part, as I said, those are practice, those are for us to do, and the lower part are theory. So let me repeat, they are theory. They are not something for you to do, okay? So I can talk about it, but if you do the things from above, okay? And if you hate the things above, you said, I will be doing that for a couple of years, and later I will become a senior engineer or software architect, then I will only focus on the lower part. There's no such a job. There's no such a job. There shouldn't be such a job. And people only focus on the abstract of things. Specifically by example is very important. It can help you to combine these two areas, okay? Where it's an opportunity that you clarify the ubiquitous language or the common language together with business people, okay? And focus on the domain. But yet it's still part of the TDD family, okay? If you look at TDD practice in general, there's a part called specification by example. It's actually the same thing as what they call ATDD, and BDD is the same thing. Okay, it's just you can understand it's a TDD with the business focus. Okay, that's one thing. Okay, the new thing, as I promised, I'm going to share is what we call the current architecture workshop. I think this is such a brilliant idea. I learned from Craig Lahman a long time ago. Have been doing it wrong for many, many years, and this year I learned it again from him. Hopefully this time I learned it right. Okay. So the current architecture workshop. Okay, I think that the name itself is inspiring already quite a lot. Many architectural workshop or domain analyzing workshop is about the future. You're planning the future. But this one is about what you already have, okay? In the workshop, the technique we use is called the N+1 architectural view model. If you Google, use a different term. You can use 4+1 because that's the original name, 4+1 architectural view model. Are you interested in the 4 or the 1? I guess 1, right? Because 1 is, why there's a 1? The 1 is the scenario, okay? Or if you're old enough, it's the use case. You choose one use case so that you don't talk about everything. Because normally the software is so big, okay? You choose one use case, okay? And then you put them on a different view. So what about if you look at the problem from the logical view? A logical view can be the, for example, class diagram or the object diagram. Okay, how the things are organized together. And another view could be the development view or the process view, how the things interacting with each other, like the sequential diagram, etc. And physical view, how the deployment and packaging work together. So you get your best people to draw them on this is a workshop. First you get your best people, people who think they understand this probably better than the others. They will draw it on the flip chart or on the whiteboard. And after that, you go to each view, okay? Everybody gather together and you start to explain. So this is what we have. This is our current architecture. And people start to ask questions and you answer. In the meanwhile, what do? You also video record it and it will become your document, okay, your architectural document. How often do you do this? several months, so that you get updated. Okay, I find it pretty useful even when I was doing it wrong. The part I'm doing it wrong is I'm actually doing only the logical view. Not this time I learned should be also combined with other views. And the reason curriculum call it n+1 is it's not really 4. It can be less than 4 or more than 4. Just as long as they are useful. Okay. Next thing is with whom you do that? Everyone. Okay. And like this is another example. Yeah. Do you recognize this one?
The midnight code review.
Yeah. This is what we call the current architecture workshop. Okay? And that's it. Oh, wait. The last one. So to achieve this, you will need to probably go on at least 2 new journeys, which the programmers, developers didn't realize before. Later in Bob's presentation, he will share this. Okay, I think most relevant to my talk is the programmer to product developer journey. You can take a picture later. Okay, that's what I want to talk about.
To pick your brain further on what you said about the dilemma between like over-designing versus starting from where you are, right? But what do you usually answer when the developers say, like, I want to know everything and like really do a proper design before I even code?
Well, because what I'm talking about is not really about knowing everything. It's about knowing everything in the domain, right? So again, from curriculum, he mentioned that the domain model is for inspiration, not for transformation. Okay, I use this opportunity to cover my missing slides. So again, let me repeat. Domain model is for inspiration. It's not for transformation. What does mean inspiration? When you are refactoring your code, you create a new class. You're like, this is a missing domain concept. What is it? And then you look at the domain to find out what it is. Okay? Rather than, okay, I figure out there's this concept in the domain. Let me create a class in my code. The class might not be useful.
Thank you.